All right, welcome back. So today we'll talk about objects and type aliases in TypeScript. Okay, so the core idea we are going to be discussing today is that, in real software systems, everything is an object. When we hear object-oriented programming concept, so when we are designing the software, we are looking at everything to be objects. So users are objects, wallets. In case, let's assume now we are building a fintech app. Of course, there will be users of the application. So these users are objects, wallets, object transactions, products, API responses. These are all objects. So TypeScript help you define what shape your data should look like. Do you understand? So whenever you want to work with any data, you can define it beforehand what the shape would look like. So that is where we use objects and then type aliases. So this is what object typing and type aliases solve. So with this feature of TypeScript, you can actually create objects. You can with TypeScript, you can use object-oriented programming concept in designing your systems. So let's take a look at objects in TypeScript. It's obvious that some of you know objects in JavaScript. Okay, so but it's almost the same thing because you already know that TypeScript is a subset of JavaScript. So look at this object that we have here. The only difference is that we gave this object a type. The user is a variable, and we gave it a type. So, of course, you know that in TypeScript, when you want to declare a type of a variable, you use the colon. So, if I go to my Visual Studio Code now and do something, oh, sorry about it. This is not what I'm supposed to open. Okay, so, okay. So, I open this in Visual Studio Code. Okay. So, I have this file. All right. So now this is what I want to do. Normally, if I want to create any variable, if it is in JavaScript, I will say user is equal to this. I will say name is John, and then age. I will say age is 78. Now this is JavaScript, and you can also see that it also works in TypeScript too. All right, it works in TypeScript. But the thing is that we are talking about object TypeScript here because we have to make use of the type. So in this case now, we do not have this our object. We do not specify any object before. So if you want to specify the data type, sorry, if you want to specify the data type, you use the colon. Then, okay, let me do something. Let me say, I want to create a simple variable. I can say const age is equal to 40. Okay. Now I can say age is of type number. So with this now, I have given it static typing here. I have done static typing here. Okay. I have explicitly declared its type. This is in TypeScript. Now, if I want to also, this user should also be a type. I could also now say, okay, this user, the data type is, I put colon, then I would create this object. I will say name is a string, and then age is number. So this is a data type. I've given it a type here. So if I go on now to say, okay, I comment this age out, there'll be an issue. Look at it, there is a problem here. It's saying that age is missing because I have given it a type. All right, I have given this object a type. All right, it says that age is missing. So these are this is one of the advantages of using TypeScript. No, so I cannot mistakenly or even out of omission make this mistake. So now everything is okay now. So here our user has this type. Our user has this type. I can also take this out, and then I can do what we call type aliasing. I will use the type keyword, and I will say I will give it a type user, and I will say is equal to this. And then I will now say the type here is this. So everything is still okay. But with this type alias I just did here, I can reuse this user data type. But if I just had coded it the way I did it before, I cannot reuse it. So we'll talk more about type aliases later on. So when you take a look at this basic object type, normally without TypeScript, we don't need to give it a type, but here we have given it a type, and then with this type that we have given it, it actually helps us when we are assigning values to this user. All right. So now name must be a string. You cannot go on and say now if I go back here and say that name is not if I age now is a number, if I go and make it a string, there will be an issue. There'll be an issue in our the type we gave it here. Age is a number, and here we are giving 78 as a string, which is wrong. So you can see that this program will not compile. Okay, so this is one of the reasons we use TypeScript. So age must be a number, name must be a string, and it must follow this structure. It must follow this structure. So there's no extra or missing fields allowed. If I go on now to even add something else, if I say salary here, it will flag it as error. Look at it. It will tell me that type salary does not exist. It says object literal may only specify known properties. Salary does not exist in the type user. So this is the beauty of using TypeScript. So invalid object. Okay, now you can see I have shown you some examples already. This user has this data type. It has this type, name and age. And when we are assigning only name, and we are not the age is missing. So it will flag it as an error. Try it out. You have seen me do that already. So age is missing, so it is wrong. It will not compile. All right. You have to provide the missing field, the missing property. So here now, when we have this user name to be string, age to be number, and we are assigning this data here, name Paul, age 25. All right. I have already shown you this already. Age is a number. The data type of this age is number, and we are given a string, so it wouldn't work. All right. Also pause the video and also try it yourself. It will not work. So this helps us to enforce the integrity of our data structure. All right. So why object typing matters, okay? Without TypeScript, let user equal to an empty object. So a user.name is 10. So at runtime, there will be a problem. Because this user object is empty, does not have any properties. And here we are assigning a property. Okay? So, but with TypeScript, it will flag the error will be caught. Although we can still argue that this would also work. So let's try some JavaScript file here. So I'm going to do something. I am going to create a JavaScript file. I will say, let me say script, because that code is supposed to work, script.js. And then I will just say const user is equal to an empty object. Okay, so I'm not saying user dot name is equal to John. So if I run this code now, there is no problem here. There's no problem, because what we're actually doing is that with this, we are if the property is not available, it will add it. Okay. So, but let me take a look at this. Okay, so now, but at runtime, we are assigning 10, which is an integer here. So maybe at runtime, okay, let me show you why this will be a problem. Let me show you why it will be a problem. So if I go on now and say, okay, name is equal to John, okay, if I now go and now say console.log, I will say user.name divided by 7. See, there is no error here. Look at it. There is no error. But if I run this code at runtime, there will be an error. Okay? Yes, it is not an error, but it gave us not a number, which is not an expected result. So let me try modulus. Okay, let me now do this. If I say name is equal to 0 or maybe 10, and then I am now going to use name I will say name dot to uppercase. Okay. If I say name dot to uppercase, you can see there is no problem here. At compile time, there is no error. But if I run this code, it gives us an error. It gives us an error. But you see that this bug or this error came at runtime. So when you have shipped your code for production, that is when you get this error. But if it was TypeScript, let's go. Let me take this into TypeScript. Let me take it to TypeScript. You'll see the difference. TypeScript will flag it as an error right away. Look at it. Okay, first of all, okay, we have this user. Let me comment it. So you can see, look at what we are having here. We are having compile time error. So this cannot compile. So this is better that it's better that we know about the errors at compile time instead of runtime. So what is a type alias? A type alias is a way to create a reusable name for a type. Just like you saw me do here. I created this, I have this data, I have this structure. So instead of me to be, okay, see, with that type alias, this is what will happen. Let me show you what will happen. With that type alias, okay, I'm going to do this. Okay, let me take this out too. With that type alias, this is what I'm going to do. I will now say user is this. Then maybe if I want to create another user, I will now say this is user 2. But just look at, they're having the same structure. And if I want to create another one, I will go on with user 3. And you can see that I am just repeating myself. The same structure, I'm just repeating myself. That is the reason why instead of me doing this every time, I will just have to take this structure and then give it a type alias. Here I have given it user. So the keyword type, then user is equal to this structure. So instead of me repeating myself here every single time, I will just have to use the user. You can see there's no more repetition. Okay, there's no more repetition. I am typing less. And if there's any reason I have to make any change here, if there's any reason to make any change, that change, I will make it at this place that I declared it. I can go on and say, let me add salary, salary, but maybe I'll just make it optional so that it doesn't break my code. And then this is going to be number. So if I make any changes here, I will just have to, this is where I make the changes. But if I have had it all over everywhere, imagine if I have it in 10 different places or 20 different places or even 50. That means if I want to make any change, I will go over and over again, making the changes to all the places I had it. But in this case, now with the type alias, I'm just making that change one place, and then I'm no longer repeating myself. So this is actually good coding style. So it helps us to create a reusable name for a type. Okay, so the basic syntax is this. You use the type keyword, then you give it a name, then equal to the data structure. Equal to the data structure. Do you understand? So the data structure, the structure of your data, of your type, depends on your business logic. So then how do you use it? You have seen me use it already. So in this case now, user is now of type user. Okay. And then instead of repeating this thing I just showed you, we are just using this. Okay. We are just using this. So this is called the drive principle. Don't repeat yourself. Whenever you find yourself repeating the same code, whenever you find yourself writing the same code like 2 times, it's either you put it in a function or you put it in a type. Okay. So real world object modeling. So let's assume now we are writing a fintech application. So this example is this. So we can see that we have a type wallet. Do you understand? So this is type wallet. So this is type aliases. So instead of us having this structure everywhere, we could just have it one place and we can export it. We can use it everywhere in our program. We can also have the type transaction, because of course your transaction always happens in fintech application. A user must have a wallet, something like that. So we are creating objects for them. So this is object-oriented programming. Yes, we have not talked about classes and interfaces yet, but this is a good start. Okay. So objects can also be nested. An object can contain another object. So if you're familiar with your JavaScript, you know that objects can contain objects. So in this case now, the structure we are having here is that this user has name, has address. Now, the address is also an object. This is very, very possible. So the address, instead of being a single value or a primitive data type, it is also an object. So in this case, we could also have the address type alias too. Okay, so let me show you. So I would also create a type. I will call it address, and it's going to have this structure. It will have, let's say, home. Home is going to Home is going to be a string. Office is still going to be a string. Maybe email. No, no. Okay, let's just work with this only. So now I can come here and now say that this user data type also contains um, address, and this address is of type address. Okay, now you can see now that because we are using TypeScript, TypeScript have actually told us, oh, this needs to, you have to also provide the address property here. So now I can go on now and now say address is of this type. I will say home. Okay, home is this, office is this. All right, so you can see, but maybe I will just have to take this one out or comment it. All right, because I don't want to type too much. So you can see what we have here. Very cool. So you can see now that our user data type contains another object, address. Okay, and this is how we made it work. So I have shown you the real word use. You can see now that in this case now, our user, we provided address, city, country, whatever you could have there. Okay. So we also have optional properties, and I've already shown you that already. So when we talked about optional properties in functions in the last class, we use the question mark. So with the question mark, okay, we have made this salary property to be optional. If not, this would have given us an error. You can see that we don't have any salary field here. But if I take this question mark out, you can see now that this is complaining that we need to provide a salary field. But if I want to make it optional, I'll just put the question mark. So how do you make some properties optional? You put question mark. So in this case, the question mark has to come between the variable and the variable and the colon. To aid may exist or not exist, and TypeScript will not complain. So in this case now, we do not have age. We do not have age, okay? So we can also make some properties read-only. When you make some properties read-only, they cannot be changed. Okay, so if I go on now and say, okay, the name is read-only, I'll just have to use the read-only keyword. And now I cannot come here and say user.name equal to this. There will be an error. Look at it. It's telling us that name is read-only. We can only read it. We cannot assign it. We cannot change the value. We cannot modify the value. All right. So that is the thing here. Okay. So read only cannot modify. You can modify any field that is. So if you want any field in your type not to be modified, you use the read only keyword. So it is used in database IDs because, of course, you should not change. Database IDs were generated from the database. It cannot be changed. Transaction records you should not be changing transaction records. Immutable data. So any data that you don't want your users or anybody to mistakenly change, you make them read only. You can also have union types inside of objects. So in this case now, we have transaction status to be either pending, success, or failed. Okay. So this is the union type. So, and then let me show you a couple of things you could do with the union type. I could say that age could be a number or a string. Do you understand? So it means that even if I come back here now and make age a string, there will be no more error because the age can either be number or string or even Boolean. So, but you actually have to use it if it is necessary in your business logic. So you can see, I can also say no. I can also say, okay, um, let me have another variable here, another field. Let's say, um, let's say, let me just use status. Okay, this status can be, it can be married, it can be single, all right, or it can be married, or it can be divorced. Do you understand? So what it means is that, okay, let me take this thing out. What it means is that I cannot give value, I cannot assign any value other than any of these three. So look at it. If I now come here, I want to say, I want to add status, all right? If I go on, look at it has given me the three options I have here: divorce, married, or single. If I go on and say blah blah blah, there will be an error. It says blah 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 is not assignable to any of these union types that I have here. So it must be one of them. It's either it is single, okay, or married. Do you understand? So this is union types. You can actually use it in the primitive type, or you can use it like this. So why this is powerful, instead of status to be done, all right, you cannot assign done to the status. It can only either be pending, success, or failed. You cannot assign anything other than the types that we have here. So in this case, we enforce strict rules. All right. So type aliases versus interfaces. So we'll be talking about interfaces in our next class, but we have something we also call interface. You can see that they look alike. The only difference is that here we are using type to declare, or while we are using interface keyword. So we're either using the type keyword or the interface keyword. Okay. So we'll talk about interfaces in the next class. The difference is for objects, use type alias, or you can, if you can use for objects, you can use type alias or you can use interface. For unions, you cannot use union, you can use unions in type alias, you cannot use unions in interfaces. And then extending, you cannot extend the type alias, you can limitedly extend type aliases, but extending interfaces is powerful. Don't worry, just this is just to bring it to your notice. There's something called interfaces. If you don't understand it, no problem. We'll talk about that in the next class. So there's something we call index signatures. Now, this is also advanced. This is also advanced, but I just want to bring it to your notice. If you can grab it, grab it. If you cannot grab it, no problem. So what are index signatures? Sometimes when you're working, if you have started building applications, you will understand that when you're getting data from what's it called? From APIs, all right? When you make an API call, you're not too sure of the data structure. You're not too sure. So because you're not too sure, you can now use index signature. So this is what index signatures allow you to define objects without dynamic keys. Let's assume that you want to create a type, but you're not too sure. You're not sure of the keys. Look at what we have done here. We know the keys. We know that this user will have name, age, salary, and all those things. But what if we are not sure? What if we do not know it beforehand? So let me say something like type wallet. Let's assume I'm a front-end developer. I do not know the type. I do not know the type, the fields of this wallet type. So what I can do is that I can do something like I can use index signature. I can say key is going to be a string, and then the value must be, let's assume, string. So what I have done here is that I can now come over here and I can create wallet of type wallet. Okay, and I'm going to assign this. So I can, oh, sorry. Sorry about that. So I can add any number of keys. I can say name. Okay, I can say name is whatever it is. I can say age is whatever it is. Do you understand? So look at it. I do not name and age. I did not declare them here. So when you have this kind of situation, you are not sure of the keys or the properties of a type, you can use index signature. So here we are saying that the key must be a string and the value must be a string. So in this case, now the key can be anything. So this is like a general. The key can be anything, not just it can. The key can be anything, but the value must be a string. So the key can be anything, but the value must be a string. If I go on now to say that the value is number, then we'll have some errors here. Okay, we'll have some errors. So I'm going to explain more. So this is called index signature. It's somehow advanced, but I just want to bring it up. So now you don't know the exact property names beforehand, but you know the type of the values. So you're expecting that you're expecting a data from an API call, but you are sure that all the data, right? All the data, it could either be a string or let's assume now wallet. Wallet could either be a string or we can also use union here. It could either be number or it could either be Boolean. Okay, so it means that this can take in anything. Sorry, it means that it can take in anything. Or if you have something like this, you could actually make it any. Do you understand? But you can actually narrow them down if you're sure of the data value. So I'm just showing you examples of how you can run this. So the basic syntax is the name, just our normal type aliasing definition, and then we make it this way. So the key is a string. So it can either be a string, a Boolean, or anything. This is a general one. This is a general index signature. The key is string, but the value must be the value of the keys that we do not know. Whenever we are declaring them, they must be strings. So it means that the key is string, any property name. It can be any property name. It's dynamic, but all the values must be strings. So example is this. So the dictionary is what we created in the previous slide, and then these are the values. So just try it out yourself. Okay. So keys can be anything, but values must be strings. All right. So why index signatures? We use index signature when you don't know the keys in advance. You don't know the keys of the data structure of the type. You don't know the keys. So the data is dynamic, API responses, configuration, file objects, and then maps. So real world examples. So in this fintech wallet balances, we are not sure of the balances, but we are sure that it's a string. It must not be, you can give this currency, can be key, can be anything at all. Try it out. It can be anything. Okay, it must not be key. It can be anything, currency, whatever you can call it. In this case, now we are saying that the keys of this balance type are going to be any data type, but their values must be numbers. So their values must be numbers. API responses, this is another example. API configuration files. In this case, now we are saying that it could be string, it could be number, it could be Boolean, that's the value. But now the key or the property name can be any data type, because if the key is string, it is like general. Okay, so look at this. Our config data type has app name to be string, version is 1, and its life is true. So this union task we have, they have actually covered everything. So if you want to make your index signatures to be more strict, what do? You can use the values. You can give it strict values. You can restrict the values. It can be admin, user, guest, whatever it could be, single, married, whatever it could be. All right. So example is this. All right. So important rule: if you define an index signature, all properties must follow that type. If you define an index signature, all the properties must follow the type for the value. So when you have defined key here, you said it's string, and here you're not saying age is number, it will not work. The data type for all the values that can be assigned to this is strings. It must be string. So here we are not saying age is number. No, it will not work. All right. So all of them have to be string because we have created an index signature here. So all of them have to be string, or you can now say string or number, okay, to make it more. So we can also make these keys to be numbers. So in this case now, instead of having anything, any data type as the key, in this case, we are having it as numbers. If you change that number, that 0 or 1 to be any string, it will fail. Just try it out. The key, the index, the key must be numbers. It cannot be string. We have restricted it to be number. Okay. So you can also make your key, your index signature read only. All you have to do is to pass the read only keyword, and people cannot modify it. They cannot modify it. So index signature versus normal object. So use index signature. The keys of a normal object are fixed. They are not dynamic. You cannot add them later. But for index signature, we make the keys, the property names to be dynamic. We can add. For structure, normal object is very strict, but index signature is flexible. And in use cases, where do you use normal object? If you're sure of the data structure that you're receiving, use the normal object. But if you're not sure, use index signature. So I would want you to practice this as your task. Create a user model, all right, that will have ID, name, email is verified. Then create a wallet model, the same thing. Make sure you post it on LinkedIn. Post it on LinkedIn, okay? Create your transaction model, sender. It should contain sender, field, receiver, amount. Okay, status. Also create nested objects. Your user should have address, city, country, and then create a dictionary object too. Okay, so thank you very much, and I will see you in the next. If you have any issue, any complaint, come to the community, let's talk, come to the platform, come to WhatsApp, DM me, however you can contact me, okay? Thank you very much, and I'll see you in the next class.